My topic, as indicated here, is a little more general than what was discussed in the roundtable, but it's the same general topic, and it concerns road transportation, mainly cars, but I'll speak a little bit about trucks as well, and environmental policy. So there's the outline, and you'll see that as the talk progresses, I'll shift from a worldwide perspective to a European perspective, down to a French perspective, and then back. And I hope it'll be clear the context as the talk proceeds. So how important is the problem of carbon emissions from road transportation? Well, you probably know it's pretty severe. Here's some statistics. In the European Union, responsible for about 30% of emissions. In France, a little bit more. Worldwide, it's lower. It's about 15%. But of course, the emissions per capita are much higher in Europe and other parts of the north. And the road share is a majority. In the European Union, it's about 3/4 of transport emissions. And in France, it's close to 100%. Right? So there's a lot of emissions from road transportation. And how costly is that? Well, economists like to calculate what they call the social cost of carbon. And the estimates are indicated in this short list vary widely. And they take into account not just emissions from carbon dioxide, but also methane and other anthropogenic sources of greenhouse gases. So in France, as a sort of a benchmark statistic, 100 euros per ton of CO2 equivalent. A study by Lint Barrage and William Nordhaus, who won the Nobel Prize in 2018, about the same figure. And then a group from the Resources for the Future in the United States coming up with a value about twice that. And then a very recent working paper, which I haven't had time to read yet, coming up with a huge figure, $1,056, which I translated to 983 euros. And this reflects the tremendous difficulties in coming up with these estimates, and also the wide range. There's some estimates which run well into 4 figures. Even if we take just 100 euros as a benchmark and calculate or apply that cost to all the emissions, we come up with a very significant problem, I think is clear from previous talks. Now, Andre, in the introduction this morning, talked about uncertainties, and I think that's something of tremendous importance to take into account. Here, a list of uncertainties. How quickly is the climate changing? What are the magnitude of the cost in terms of warming, extreme events, sea level rise, etc.? And then the human element, there's uncertainties about attitudes, how they change towards the environment, the rate at which emissions reductions are underway, and also adaptation, accepting the fact that the climate will be warmer and figuring out what to do about it, acceptance of environmental policies such as carbon taxes. And we know from Gilets jaunes and demonstrations elsewhere in the world that there's substantial pushback. And then governments. One government may adopt a green policy, but then they get replaced by another, which reverses some of the initiatives. And that was clear right here last week in the European Parliament. And then technological uncertainties as well. And some of those are discussed in the round table, so I won't go into that. Another set of challenges concerns externalities. Right? The AICC and the talk so far mainly focused on CO2 emissions, although local pollution was mentioned, particulate matter and so on. But there are many other important externalities which also should be taken into account. And if you implement policies aimed at greenhouse gases, that'll have knock-on effects, quite possibly positive, but also possibly negative, on all these other externalities. And the third consideration or challenge is people's behavior, which Marcia Benekiv will be talking about later. So people are not fully rational, they are boundedly rational, and they may make mistakes. One common mistake is when you buy a vehicle, you focus on the sticker price and you focus on the features, but you disregard or discount how costly it will be to operate that vehicle for 15 or 20 years, the energy consumption, the maintenance, etc. So people can make mistakes, and then firms, which of course are accommodating the preferences of the people, they can make not mistakes, but in a sense socially suboptimal decisions by focusing on engine power and less so on things like fuel efficiency. Now, there are many regulations, and I don't have space to discuss many of them. Here are some at the worldwide level. How many countries have adopted policies more or less stringent? How much money is generated from instruments such as carbon taxes? Well, fourth bullet point here, a little over $100 billion US. How is that money used? Well, over half of it to green investment. Is that a good idea? Well, many people would say yes, but there are two other ways in which the money could be used. One is to rebate the money to the citizens, so lump sum rebates, either on an individual or household basis. That's what's happened in Canada, and it was rather unsuccessful because people did not associate the rebate with a tax. It was just marketed very, very badly, and that policy was only recently rectified. And the other use is to reduce other so-called distortionary taxes, such as the income tax. Economists tend to favor that, but most other people don't. So economic efficiency may not be fully respected in the policies that actually get adopted. So moving down to the European level, what sort of regulations are there? Well, a number have been mentioned already today. This is just a small sample. Emissions trading system was introduced nearly 20 years ago. Current price of the ETS is about 80 euros per ton of carbon equivalent. I'll come back to that because it's relevant to the little calculations I'll be doing. Fit for 55. The ban kicking in 2035 on sale of new internal combustion engine vehicles. That's also going to be featured in this calculation. Carbon border adjustment mechanism also legislated last year, which will be coming in the fairly near future. And then a parallel emissions trading system, so-called ETS2, which is scheduled to come in 2027 for road transport. So the current emissions trading system does not cover everything. Right? It covers aviation within Europe, but not international. It covers rail, but it doesn't cover road or heating fuels. Once the system is introduced, the price may be limited, right, to provide an adjustment period, and it's going to affect the price of petrol and diesel. This is just estimates, 10 or 12 cents per liter. Moving down further in a geographical scale to France, what policies are in place regarding BEVs, battery electric vehicles? Well, you can think of them as carrots and sticks. The sticks apply to the internal combustion engine vehicles, and one which is perhaps not so obvious is that there are high excise taxes on fuel. It's of order €1 per liter, and that translates to $200 to $300 euros per ton of carbon equivalent. So comparable to some estimates of the social cost of carbon. And there is an explicit carbon component, a much smaller value, about 45 euros. And then there are penalties on the sale of internal combustion engine vehicles. They depend on the vehicle weight. Unlike electric vehicles, where there's still no weight dependence. As far as electric vehicles are concerned, there are two forms of support. One is that although electricity is taxed, it's at a much lower level on an energy equivalent basis to the fuel taxes. So once you have your electric vehicle running, it's more efficient thermodynamically, and then on top of that, you're paying less tax. And then the more obvious advantage are the subsidies for a purchase of a new vehicle, and then a smaller subsidy for each time the vehicle is sold to someone else. And in some cases, these subsidies are means tested, so they depend on the household income. And there were some recent changes to that. I may not have time to mention them. So the carbon tax is essentially like a fuel tax, and fuel taxes are pretty much ubiquitous. So how good are they as an instrument for internalizing externalities? Well, they're a perfect instrument for CO2 emissions, right? Because the emissions are a function of how many liters you consume, and that's how the tax is based. So score very well in that respect. But for local pollution costs, which depending on the setting can actually be more socially costly than the CO2 emissions in a dense urban area where your fleet is still pretty dirty, not a good instrument. Right, because the costs depend on population exposure, so it depends on where the roads are compared to the population. And then in practice, the further of faults in fuel taxes. In the main, going back many decades to when fuel taxes were introduced, it's mainly to raise money, to pay for roads and possibly to cross-subsidize public transit. So not primarily an instrument for internalizing externalities, let alone environmental externalities. And then if we look across the OECD or even within Europe, the rates vary rather considerably, and even within countries. If you compare states in the US and provinces in Canada, quite some variations. And then even worse, some countries, mainly in the developing world, subsidize fuel to the tune of over $1 trillion, according to this World Bank survey. So if we bring all of that together, what do we get? Well, you can summarize it in this bar chart where we're plotting 2023 US dollars, the effective tax. Well, the carbon tax contributes, but a small amount. Same thing with emissions trading. The net fuel tax is shown in purple, around 40 euros or 40 US dollars per ton. And then we have below the horizontal axis the subsidies. And this is a worldwide average, much greater in some countries than others, adjustments for VAT. And the total effective carbon tax is shown by the thin green line, which averages around 40. Well, how does that compare with the social cost of carbon? Much less. So although fuel taxes are discouraging consumption of fuel, it's only a fraction of what is estimated to be the social cost. So now let's look specifically at electric vehicles and internal combustion engine vehicles in France. And this reflects joint work with Andre and Yannick done late last year. So we're projecting how the fleet will evolve as we approach 2035, the ban on the sale of new ICE EVs. We assume that the size of the fleet does not change, about 38 million vehicles, and then the ICVs are progressively replaced by battery electric vehicles, and then you measure the emissions using this WLTP procedure, which is quite widely used. So here we have on the horizontal axis 2020 up to 2055. The dashed line shows the sales of the battery electric vehicles, a little more aggressive, I think, than what we're seeing so far. 9% in 2022, increasing rapidly to 40% in 2025. Probably not going to get there that quickly, but we assume that the ban is effective and only battery electric vehicles are sold by 2035. What about the fleet of vehicles? Well, of course, that adjusts with a lag because it's a stock rather than the flow. But you can see by 2050, almost all of the ICVs are off the road, and by 2055, essentially all of them are. Correspondingly, CO2 emissions drop from about 130 grams per kilometer currently down to 0 in 2055. So road emissions from cars will be eliminated if the ban holds, right? But there's some question as to whether that'll happen or not. And even if it does, it's going to be quite costly to the government because of the subsidies I mentioned, the low tax on electricity and then the purchase subsidies. So what we did as an example was to consider a household which wants a Peugeot 208, but instead of buying the ICE EV, they buy a BEV. And then they drive it the same distance, so it's a apples to apples comparison. And then we compute the cost per ton of CO2 eliminated by having the BEV, and that's on a lifetime basis. So what are the total cost of the purchase subsidy and then the subsidy on the consumption of the energy divided by the total reduction in CO2 emissions from the manufacturing of the vehicle and then the emissions during its lifetime. Well, here's a summary of the table. Some of these statistics have come out in earlier presentations. So per kilometer is about 118 grams of emissions from the gasoline version, a little bit less from the diesel because it's a more efficient engine. And then the BEV is much lower, but it's not zero because even in France, which has a lot of nuclear, it's not 100% green. Right? So you're getting roughly 10% of the CO2 emissions for the battery electric version. Assume the vehicle has driven 160,000 kilometers in its lifetime, a little bit lower than the figures discussed in the round table. So you get these numbers, 19 17 and 1.8 tons, but then you have to take into account the manufacturing. And since we're assuming it's the same vehicle as far as the body's concerned, that difference nets out, so it's not in these figures. But the BEV has a much bigger battery, and the battery is rather CO2 intensive to manufacture, right? So the difference is 4.7 tons. So if you add things up, you get 18.5 tons of CO2 emissions for the lifetime of the sales-weighted average ICEV, and about a third of that for the battery electric vehicle. Now, I mentioned the emissions trading system. It comes into relevance here because there's an overall cap on CO2 emissions. So if you have a household which is now driving a BEV, it took electricity to make it and then to operate it. To meet the cap, other uses of electricity or CO2 emissions have to drop by the same amount. So the net increase is zero. Right? And that's the case, then you save the full 18.5 tons for the lifetime of the ICEV, whereas in the hypothetical world where there was no ETS, what I call here unconstrained, it's only a 12-ton saving, the difference between the two vehicles shown in the previous table. Now, another uncertainty, which I mentioned, was the political one. We have a policy currently in place, but will it persist over the 13 or 14-year lifetime of the vehicle? Quite likely not. So we consider these scenarios where the new sale subsidy, we assume, remains in place, but perhaps not the resale subsidy. And then the electricity tax, maybe that'll go up to be comparable with the tax on gasoline and diesel. Under the ETS constrained scenario, you come up with these figures ranging from 200 to 560 euros per ton. And then in the unconstrained, it's a little over half again, right? Because it's a 12-ton saving rather than 18 and a half. And then you're getting 300 euros to 870 euros per ton saved. Quite a substantial figure, much higher than the current price at which permits are trading in the ETS system, about 80 euros. Now, is this unusual? Is this just because France is atypical in terms of the cost? And the answer is no. International Transportation Forum has a survey and reporting figures, some of which are lower, but some of which are bigger. So the conclusion from this is that if you consider the battery electric vehicle's only advantage to be reduced emissions, and subsidizing it is a pretty costly way of reducing the emissions. So the ETS permit price of 80 is lower than the social cost of carbon, and the emission costs we see here are lower than most estimates, which I showed in the previous table. Now, what about heavy goods vehicles? Well, they're important because they account for about 25% of emissions of road transport in the EU. The main challenge, as you might expect, is it's a much heavier vehicle, so it takes a lot more energy to move it, say 100 kilometers, and it's also less aerodynamic. Right? So for 100 kilometers, it takes about 120 kilowatt hours, and that is comparable to the maximum capacity of a battery electric vehicle passenger car. Well, these commercial vehicles can travel 800 kilometers in one day, so you need about 1 megawatt hour of energy, which is about 10 times the maximum capacity of a car battery. So if it's going to be an electrical truck, you're going to need huge batteries, and I'll come back to that point shortly. And it's going to be replacing diesel, which is almost the universal powertrain in heavy goods vehicles, which has various advantages. And by the way, I'm not talking about deliveries within cities where the energy requirement is much less because of the shorter distances. We're talking about heavy goods vehicles, big vehicles, multiple axles, and traveling much of the day. So what has been done, and I'll show you a table of results, is to consider 4 competing energy sources, competing with diesel, alternative liquid fuels in the 3 listed here, battery electric trucks, hydrogen fuel cell, and then electronic road systems, either containers, which are above the road, or inductance loops in the ground. And let's show a picture of the latter 2 technologies. On the left, we have the hydrogen fuel cell. It looks the same pretty much as a diesel vehicle, except instead of having diesel fuel in the tanks, you have highly compressed hydrogen. And then to the right, we have an example. I think it's a German truck where some experiments have been undertaken. And you have a catenary, which looks similar to what you have in some rail systems, as well as trams. It does cost some money, but less than the inductance loops. I don't have a diagram for that. So what this table does, and it's my own construction, so a little crude, comparing these 4 alternative energy sources in the columns with 12 criteria, and I won't go through all of them, but if you look at the column for alternative fuels, you can see there's a lot of red there, identifying disadvantages of that technology. And there's also quite a few disadvantages for the hydrogen fuel cell. Battery electric, not so much. The main problem is that you need heavy batteries, figure which is sometimes mentioned. 5.5 tons will be the weight of the batteries. And that's going to eat into the payload of the truck. If it's capable of transporting 30 tons and 5.5 is now batteries, you're losing maybe 20% of your payload. And so that's bad commercially. And then electric roads, you can see there's not much red and there's actually some green. The motor is lighter and storage isn't the problem because the power is coming directly from the overhead wire. So that suggests that battery electric and perhaps even more so electric roads are the way to go. And then there's a working paper by Maria Borgeson and Steph Prost, who was at the event that Andre mentioned, the symposium last week. And they argue that under certain conditions, the catenary is a good technology, provided you have enough truck traffic along corridors to justify the cost of building the catenaries. The main disadvantage is that you have to have a continuous network, unless you're going to equip the truck with heavy batteries, but then that's going to have the same problems which I just mentioned. So the catenary technology will probably be viable on certain corridors, large countries which have a continuous network where the vehicles can travel almost the whole distance from origin to destination with a catenary. They do need a small battery to get from the origin, the depot, and to a delivery place, but it may have only need a fairly small capacity. Now, I don't have too much time yet left. I prepared some slides on new technologies. Autonomous vehicles were mentioned in the round table. Let me just emphasize that there are potential disadvantages, even though it'll be more convenient for ride sourcing, ride sharing, car sharing, and that is it may encourage more travel, which is going to cause problems with traffic congestion, safety concerns, and so on. And that's partly because if they're electric, which they're bound to be, the cost per kilometer and the energy will be lower, and it's much more convenient. You no longer have a driver. Everyone can do other things in the vehicle, whether it's privately owned or whether it's ride shared. If it's taxi, you don't need a human driver. So the cost will be lower, and so will the time. Parking may be cheaper as well, because the vehicle doesn't need to park except late at night, and then it can go to the suburbs where land is cheaper. So you may get a substantial increase in the amount of driving. So that's a concern with the AVs when they eventually come into place. I have a slide here on advanced air mobility, but let me just say there that it's probably not going to make much difference. It is a substitute for road transportation, but it's likely to be quite expensive for the foreseeable future. So only rich people can afford to fly in an advanced air mobility vehicle, whether or not it has a pilot, let's say from downtown to the airport. It can cost several euros per kilometer, so only the rich can afford that technology. So I'll conclude with a list of the challenges for electrifying transportation, and this is from the perspective of cars, and I can go quickly because many of these points have been discussed already. For consumers, currently the electric vehicles are still more expensive to acquire, even with subsidies. There aren't as many models available in the market as there are for internal combustion engine vehicles. Buying a shared vehicle or a used vehicle is advantageous, but the supply of that is only increasing gradually. And then if you continue to drive an internal combustion engine vehicle, maybe it'll become less convenient because the number of gasoline stations will be decreasing. And if as economies of scale in refining are lost, then the cost of supplying the carbon-based fuel may increase. Right? So this is something which maybe people haven't thought about, but it may be a concern. And again, as far as the amount of driving is concerned with the battery electric vehicle, it's more expensive to acquire, but cheaper to operate, so that may induce demand. And then people may keep their internal combustion engine vehicle. Particularly Americans are going to afford to have two or more vehicles in their garage. They keep the ICE EV. It may have a higher capacity and it's good for longer distances. And much of the driving will continue to be done by ICE EVs. They're using the battery electric vehicle only for urban transportation. Environmental concerns if the vehicles are sold abroad, and that was mentioned earlier today. Government financing, I only gave you an example where the cost of the French government, the subsidies are appreciable. And then something which I don't think has been mentioned, richer people will decide to buy a BEV whether or not there's a subsidy. Well, if there's a subsidy, they'll gladly take it, but it doesn't affect their behavior. So that's money that's wasted from the public perspective. And then another major consideration, if ICE EVs are no longer being manufactured and operated, the government's going to lose a lot of money. VAT on the vehicle sales, after-sale service, registration fees, fuel taxes of order €1 per litre. And there's a study done for the United Kingdom, here shown at the bottom of the slide, showing just how big the fiscal effects will be. Challenges for the automobile industry. I'll skip that because that was discussed in the round table. And then this is my last slide. Recent policy developments. I mentioned the ETS2 coming in 3 years' time. Subsidies for CO2 emissions reductions now depend on the manufacturing. It's not just the operation. There's a bit of a tightening in France for what subsidy can be provided for the purchase of vehicles. A reduction in the size of the purchase subsidy for high-income earners. And then if we look worldwide, similar trends, and in some cases quite rapid. I think it was in December last year that the subsidy in Germany was eliminated, and that's because of for financial reasons, not a change of thought about the environment. Targeting incentives at low-income households, that's considered in some U.S. states. And last two bullet points. Since the battery electric vehicles are not paying fuel taxes, well, governments want to continue collecting money for them, so it could be done by charging higher registration fees than they do for the internal combustion engine vehicles, and then something which has been thought of for many years, particularly in the United States over a decade, distance-based charges, which will be the same for the ICE EVs and EVs, which are sort of level the playing field as far as how much people are paying in the form of user charges to operate their vehicles. So that's it. Thank you very much.
Thank you for a great presentation. I'm Youssef El-Yacoubi, first-year PhD student in Beta Strasbourg. Is there some studies that say what would it take in terms of electricity production to have 100% BEV cars in 2055?
That is a concern, and even in Canada. Last month I heard a presentation at a conference looking at Quebec. Now, Quebec has very good hydropower. However, most homes are heated with electricity, so that's already a substantial demand. And this study examined the effects on electricity demand of electrifying all the vehicle fleet, cars and trucks, and it was going to approximately double the electricity demand. And the opportunities to expand hydropower, even in Quebec, are somewhat limited. So it's an appreciable concern about whether there be substantial enough electricity capacity. I'm from British Columbia, which also has a lot of hydro. Heard another study predicting that there would not be immediate problems with capacity, but it could be coming fairly quickly. And then there was a power outage in Alberta, the adjoining province, during the winter, right, because it got extremely cold and electricity demand went up. So the answer to the question is yes, there are concerns, and maybe in places where you would not expect there to be capacity constraints.
I have seen you have said that there is still some significant subsidies for fossil fuel. Could you elaborate a little bit? Because I was surprised by the amount of the value you show. What are these subsidies?
Well, they go back for decades. I think Mexico is an example. They want to keep the price of fuel low, and when they propose to increase it, you get the equivalent of the Gilets jaunes resistance, and you hear about that now and then in the press. I think the government knows it's inefficient, but for political reasons, they keep it in place. The problem, I think, is alleviating. Right? It depends if the price of oil goes down, then it's a time to reduce the subsidy, but it's sort of a ratchet effect. It's a gradual process. And over $1 trillion a year, I mean, that's a substantial amount. You can see in the bar chart that it does affect the net world average price of carbon, or the fee imposed on carbon.
Do you have data about employment? Because it's difficult to find. Is it true that if you shift completely to electric vehicles, employment in the automobile industry will decrease? Is it a lot? Is it not a lot?
I think people in the round table, and certainly Yannick, are better positioned to answer that. I think because the electric vehicles have fewer moving parts, that maintenance costs may be reduced, and also quite different skills are required to manufacture and to service electric vehicles than ICE EVs. I'll stop there, and the experts can either correct me or add.
No, definitely we don't know. I don't know exact figure, but definitively electric vehicles are simple and need less maintenance, less rework, and so on. So definitely the impact is extremely significant.
It's significant.
On top of that, you know, the way to produce vehicle, we used to have ICE vehicle used to be repairable. The electric vehicle the trend seems to be less and less repairable. The Tesla is advertising a lot about giga casting, blah blah. They make a lot of marketing connection, but these vehicles are not repairable at all. If you have a small incident, you will not repair the vehicle. You need to scrap all the vehicle, even for small incident. So the effect of the second market, the repair part and so on, will be quite significant. On top of that, if we increase the durability, that goes in the good way. You know, most of the OEM were making a lot of money on spare part. So at the end of the day, we will have to make the trade-off between durability of the car, simplicity, and employment.
Yes, on some parts, for instance, the gearboxes. You have an electric vehicle, you have a reductor. That means 3 pinions. In the gearboxes, you have 15 pinions, nearly. You see, so you take more time to machine a pinion, a gear, in an electrical vehicle because of noise. You need a very, very good quality, so it takes more time, but you have very few parts. So you can consider that all machining center we have, probably more than 50% will be not used. And the workers that are here, we don't need anymore. The same for the engine. For the engine, you have all the camshaft and so on disappear. And iron casting disappear. Aluminium casting, no. But iron casting, yes. And so, yes, it has a very large impact on employment. Very, very large.
So one additional comment. So because of this trend, because there is less part to produce in-house for OEM, basically the trend is to reintegrate the part that were originally subcontracted to Tier 1 and Tier 2. So the most impact will be on Tier 1 and Tier 2 supplier, because the big OEM, to save their employment, will reintegrate some activity in-house. And the trend is already ongoing with Stellantis, with all car makers. So the main impact will be on Tier 1, Tier 2 supplier.
And generally, we say that for an ICE vehicle, there is about 30,000 pieces, different pieces. For an electric vehicle, it's only 20,000 pieces.
So maybe I ask a question to Kathleen, since you are the nearest to the government here, probably. So I read some report and they speak about employment induced by the green transition, but what about the employment which are destroyed by the green transition? The government has some idea about how to help these people who will lose job and maybe cannot find new job because they are specialized, as we heard, in job which don't exist anymore.
If you look at macroeconomic studies, you don't find a big effect of the transition on employment at the macro level. But there are big sectoral effects, for sure. And it's difficult to know because you have people that say it will be a disaster, it is the job destruction argument, don't do the transition because of big job destruction, blah, blah, blah. And on the other hand, you have people that say, oh, a lot of green jobs. So it's very difficult to know what happens. But there will be sectoral reallocations for sure. But I think the macro effect is not being to be very huge. There are sectoral reallocations, but also there are big differences inside each sector, depending on the electric mix, the energy mix of the firms, and so on. So there will be reallocations for sure, but it's more about reallocation than macro effects, I think.
Maybe Yannick can speak about the European the perspective with respect to the automobile industry in a few
No.
seconds.
In fact, the main problem, yes, you will have a employment decrease in some sector. The problem is these people will lose their job, okay. There is a job for them, okay. Where, what price, which company? That's the three first questions that workers will ask. I remember when we have shut Vilvoorde plant, the question were very simple. And I was, when they announced that, this closed of plant, I was the alone French inside. And very, very quickly, in the 2 hours after, it was where, when, and how much. And so that is the main question we have to solve to succeed this transition. Yeah. Otherwise, and what we have in mind that very often there is cluster of production. For instance, in France, in the Cluse, near Cluse, you have a lot of small tier 2, tier 3 suppliers that are working for automotive industry. In Sochaux-Montbéliard too. And so in this, we have to take care to this region not to do the same thing that in Belgium with Charleroi. That's all.